Hey, Honors Physics. This is lesson 3 of electric fields. We're on page 11 in your packet. And there has been some kind of ups and downs this week. I'm not sure I did my best at communicating all of the major objectives, but I certainly expect you to speak up for yourself. Now, this is one lesson. This is lesson 3 that's actually very straightforward. And what I mean by that is if you have already developed, and this requires this knowledge, that if you have a source charge, and it can be a single positive or it could be a line of positives, that we know that electric fields always radiate outward from that source. So for a single positive, the charges are spread out evenly in all directions. But for a plate that's positive, that is to say a line of positives that are maybe on a surface of a conductor, right? And the field always goes away from them, and it's always perpendicular from the surface. So these are drawings of the electric field. Now this page, page 11, page 12, and page 13 are about how do you know what is going to happen to another charge that you drop into this E field. So we know that there's two kinds of things that can happen, right? If we were to drop a small positive test charge, which is a secondary charge, it's referred to as a test charge, while this is referred to as the source. Well, we know that what would happen. We knew last chapter that positives tend to repel positives. But what you notice is that there is a force on this positive charge that is going in the same direction as the E field. So whichever way the E field points, the positive charge would experience a force, an electric force, in the same direction. Okay? So the way that we describe it is that what kind of force do they feel, right? It's an electric force when you put a charge into an electric field. And for a positive charge, we would say that the force goes with the same direction as the E field. So we're going to use, and it's very casual language, but it goes the same direction or it goes with the E field for a positive charge that is placed into this electric field. Now, what happens if you drop an electron into this field? Well, we know that electrons are attracted to positive sources. And so, right, the force on the electron would go the other way, right, because there's an attraction, and it goes against. I want you to think about this as the E field doesn't change its direction. It always points outward from the positive source or outward from this point source. But the forces can either be in the same direction as the E field, such as for a positive, positives go with, negatives go against. So that's the rule for figuring out which way does a charge get pushed. So, for example, in number 1, although it is not visual, it's a verbal description, there's an electric field pointing to the right. So let's draw that. And it says, what would happen to a positive charge that is moving to the right in that field? Now, the fact that it has a velocity, right, there's a velocity to it, doesn't matter. If you drop a positive or move a positive in an E field, which way would it get pushed or which way would it experience force? Well, we know that positives go in the same direction as the E field, so it would get pushed to the right, right? That's with the E field. Now, what if there's an E field pointing up? And an E field is created by a source charge. You know, there's a source down here that's not always drawn in. If you just know that there's an electric field and it points up, and you put a positive charge in that's also moving to the right, does the fact that it's moving to the right have any bearing on the force at all? Nope. All you need to know is that a positive is in an E field, and which way would it get pushed? Well, its velocity may be to the right, but its force, right, the direction of the force would go with the E field, and so the force would be upward. Now, that might actually change its motion, because if you're moving to the right and you get pushed upward, you're probably going to curve, and we'll examine that next. So your goal is to finish this page, page 11, and try to see if you can line up. This arrow doesn't mean number 3 is pointing left. It just means finish all of these problems, right? So 3 through 6. On the next page, and we only have a few minutes left in this recording, there is an idea that I would like